Right, so again, it's additional core chemistry, and today the topic is covalent bonding. So some awesome sentences that you need to be able to use. Covalent bonding is when two non-metals, two non-metals, so we're talking about group 6 and 7 mainly, might get a bit of group 5, never going to be group 8 or 0 because they've got full outer shell, and they share electrons, Normally when we draw this, only the electrons in the outer shell of each atom are shown. So what I am going to do now is have a go at just recapping, demonstrating how to covalently bond, I want you to imagine that they said to you, show the covalent bond in HCl. So they said, show the covalent bonding in HCl, So what atoms have you got? You've got hydrogen and you've got chlorine, so you can split it up that way, Hydrogen has got 1 in its outer shell. It's not technically in group 1, but it's got 1 in its outer shell. Chlorine's in group 7. So the first thing I'm going to do then is draw 1 for my hydrogen and then 7. And I'll do them differently just so we can see what's going on. Don't have to be different. And then 7 for chlorine. Now, what they're going to do, they're not like ionic bonding. They're going to share it. So if you look here, this is why I always pair them up. There's one single pair there, and there's one here because hydrogen is the first shell, so it's only 2. So these two are going to share an electron. So the way we draw it is we draw 2 circles and we draw an overlapping region. That's the bit where they're going to share. So hydrogen is 1 electron is going to go in the little share zone, whereas with chlorine, you're going to have 1 electron in the little share zone, and then you're going to have the other 6 outside. And that's what they would be expecting you to draw in the exam, looking for the ones that aren't paired up to go in your friend or share zone. So some compounds can form double bonds where they share 4 electrons. Oxygen is an example of this. So with oxygen, they've both got 6 in the outer shell, so 2 go in the share zone, 2 each, and then you have 2 other ones outside. Oxygen is most probably the only example you need to know of a double bond, so they've got 2 in their share zone. Most covalent bonds have really low melting and boiling points, can't conduct electricity because there's no free electrons. All the electrons are in pairs or in the share zone, so they can't conduct electricity. The other thing that you need to know about is the allotropes of carbon. So allotropes of carbon are different forms of carbon that contain lots of atoms joined by a covalent bond. It's always carbon, so it's carbon bonded over and over again. Normally form lattices. These have very high melting and boiling points because they bond covalently over and over again. So if you've got loads of covalent bonds, you're going to have a higher melting point than just one covalent bond. Diamond, graphene, and buckyballs are all examples of allotropes of carbon. The two main ones that you need to know about is diamond. So diamond exists like this structure. So each carbon has got 1, 2, 3, 4 carbons bonded to it. It kind of starts to create this pyramid, but every carbon has got 4 bonded to it. Really high melting point, and they don't conduct electricity. The other one you need to know a little bit more about is graphite. Graphite is 3 carbons bonded to each other. So there's 1 carbon there, 1, 2, 3 bonds. So this time they're only bonded to 3. They're layers that can slide over each other, which means that it's quite lubricant. And the other thing is it can conduct electricity. Carbon has the ability to bond 4 times. So every carbon has the ability to bond 4 times. In graphite, 3 carbons bond to 1 carbon, but you've got one here with the free electrons. Those free electrons then have the ability to conduct electricity. Whereas with this one, this free electron would actually be another carbon bond, so it wouldn't. Again, a little knowledge test then. Have a little think about this and then pause the video and I'll bring the answers up in a minute. So, which groups are non-metals? The big groups, are 6 and 7, but obviously, like I've said, 4 and 5 have mostly members of non-metal, a couple of metal alloys, but group 6 and 7 are the big ones. Describe covalent bonding, the sharing of electrons, between 2 non-metals. Draw the covalent bonding of HCl. We've just done that one, so the covalent bonding of HCl would look like this. Just pick the same one twice. You'd have your shared electrons there, 1 coming from the hydrogen, 1 coming from the chlorine, but then the chlorine would have another 6 already paired up. Give 2 properties of covalent bonds. They've got low, melting, and boiling points. They can't conduct electricity. And they are mainly gases at room temp. Okay, a couple of liquids, but mainly gases at room temp. So quite low density as well. Describe diamond, 4 carbon bonds, really high melting point because of all the covalent bonds over and over again, but can't conduct electricity. To compare then to graphite, graphite's got 3 carbon bonds, each carbon. Still a high melting and boiling point, but this one is lubricant as well because it's got the layers which can slide over each other. Okay, and it can conduct electricity because it's got 3 electrons. Okay, and like I've said before, if you didn't get all of them questions right, you need to go back and watch the video again and then start again until you're getting all these questions right. It's a really good revision process.